Alright, Miss Howard's Chemistry. This is Unit 12, Acids and Bases, and this is Part 3. So we're on the PowerPoint Part 3. And we're still going over the teaks, and the teak we're going to focus on right now is C7b, which means you're going to write chemical formulas of common acids and bases. Yippee! So the first one you should already know is HCl. L, that's an L. The symbol for chlorine is Cl. So quit saying HCl. HCl, hydrochloric acid. There's an old term for it, and that's muriatic acid. And it's actually, many of the plants that are around here still use the term muriatic acid instead of hydrochloric acid. It's used in a lot of stuff. It's used in pickling steel, which means that you have this old nasty piece of steel that's got rust on the outside of it, and it's going to clean that off and clean off any stains and impurities on the outside of it. It's used to purify magnesium from seawater. So all that nice spiffy magnesium metal that we use in lab, we can purify that from the seawater. There's a lot of magnesium in seawater. Is it pure magnesium? Not necessarily. It could be in the form of a compound. It's found in your stomach. You guys know this already. It's found in your stomach. That's when they talk about gastric juices or stomach acid, they're talking about hydrochloric acid. And its main function in your stomach is to digest proteins. Not to digest the sugars and the fats and things like that, but the proteins themselves. When you eat the hamburger patty or the steak, not the fat in it, but the actual protein, the muscle tissue itself. Another big one, these are all actually that we're going over right now, are strong acids, which means that if you put them in water, they're really going to conduct electricity. The next one is nitric acid, HNO3. You need to know the formula for these. Nitric acid is used in fertilizer production. It's used in explosive production, so when you're making explosives, you're going to have to use nitric acid to make that. It evaporates really easy, so it's a volatile. Volatile means it evaporates easily, so it's a volatile acid. If I go get the jug out of the acid container, acid box back there, and I take the lid off, you can see smoke coming up out of it. It's very volatile. And it does stain proteins, so it'll actually stain your skin if you get it on you, and you're not going to like getting it on you anyway, so don't get it on your skin. Next one is sulfuric acid, H2SO4. Sulfuric acid is huge, huge, huge. Sulfuric acid, the U.S. produces more of this chemical than any other. Sulfuric acid is one of those indicators that tells how well a country is doing economically. How much are they producing? The more they produce, the better they're typically doing economically. It's also used to produce paper. It's used to produce fertilizer. It's used over here by Phillips Petroleum. ConocoPhillips in refining of the oil. It's used in car batteries, and geez, almost every industry. You know, if you guys get a job at one of the plants around here, again, not only will you see hydrochloric acid, muriatic acid, but you'll also see sulfuric acid. You'll have access to that in many places, so you always need to be aware of that. You know, if you have a car battery, inside of that is the sulfuric acid, and that's really nasty, nasty stuff. Don't mess around with the batteries in your cars. Let me say that again. Don't mess around with the batteries in your car, children. Alright, phosphoric acid, one of my favorites. This phosphoric acid is really one of the main flavoring agents in sodas. Now, your soda also has some carbonic acid, but one of the big flavoring units is the phosphoric acid, H3PO4. It's a weak acid, which means that it doesn't conduct electricity very well. It will a little bit, but you know, not as well as the hydrochloric or the nitric or the sulfuric. It's used in manufacturing detergents, you know, like dishwashing soaps and clothes washing soap. It's used in the manufacture of fertilizer. So there were three that we just used to make fertilizer. Phosphoric acid, sulfuric acid, and nitric acid. Fertilizer, it's no wonder that they can build bombs with fertilizers. Another one that's really, really common is acetic acid, HC2H3O2. And it's used in the production of plastics, which we don't usually associate vinegar with doing that. It's used to make medicines, pharmaceuticals. It's used to, obviously it's present in household vinegar. It's used to preserve a lot of food, so it's used heavily. The next one, and I have a video we'll see in class that deals with acetylsalicylic acid, which is aspirin, so we'll see that when you guys come back into class. Now, we also have some examples of bases, and really, the acids are much more, in many cases, much more common. Those are the more common things we see in the household. A lot of the foods that we eat have some of those acids. The bases, when you focus on, you see, well, what things are made up of bases, you really see a lot of cleaning agents. The first one is sodium hydroxide, NaOH, and it's lye. That's the old name for it. Second one is potassium hydroxide. Notice the hydroxide ion in there. So we have KOH. And then we have magnesium hydroxide, MgOH2. And finally, another big one is calcium hydroxide, otherwise known as lime. Not the lime that you eat, but a lot of times you'll see this used to, people put it in water, say water that they get out of a pond or a well, and they treat it to clean the water, make it drinkable.